Welcome back. So let's learn what is center of tendency. This is a very important topic for statistics because it covers this topic will cover mean, median, mode, and you will be going through with this everywhere, even up to the Gaussian models or everywhere. Okay, let's start with in statistics, a central tendency is a central or typical value for a probability distribution. May also be called a center or location of the distribution. So, for example, you have this distribution, it will tell you where your distribution is, the center of the distribution. Okay. Measure of central tendency are often called averages. Now, averages is mean, okay, and mean is divided into harmonic mean, geometric mean, root mean square. Now let's understand all three of them in detail. So let's learn first what and when to use harmonic mean, arithmetic mean, geometric mean, and RMS. You will get loads of MCQs on this topic. When the rate are expressed x per y, we use harmonic mean. When x is fixed and y is variable. For arithmetic mean, when x is variable and y is fixed. So for you won't understand this way, but if I give you the example, x is fixed, distance traveled at a different speed. So x is fixed and that's your distance. So for example, 100 miles, but you are driving with different speed. At that time, you will use harmonic mean. Okay. When x is marks of student is fixed, exam y. So exam y, for example, that's your, ignore that. Your exam y was probability exam, okay? And your x, your marks are different. Some student have scored 5, some student have scored 6. So this is where you will use your arithmetic mean. Now, x is height of a person in a fixed area of locality. That's where you will use arithmetic mean. Now let's understand the difference between geometric mean, average rate of investment. That's where you will have the geometric mean. Average percentage of change in a salary. Percentage incline or decline in population. That's where you will use geometric mean. So if anyone give you a question, there are X amount of population and that has grown this much, which method to use? You will use geometric mean. That's your answer will be. Now let's understand what do we mean by root mean square. Root mean square is the square root of the mean square, which is the arithmetic mean of the squares of a group of values. We will discuss the formulas of each of them that will explain you in detail. RMS is also called a quadratic mean in a special case of the generalized mean whose exponent is 2. Root mean square is also defined as a varying function based on an integral of the squares of the values which are instantaneous in the cycle. Now let's understand this by formula. So when we have root mean square, it's useful in electrical engineering. Like I said, it's also called quadratic mean. Arithmetic mean is simple average. 4 plus 5 divided by 2, 6 plus 8 plus 7 divided by 3. Geometric mean is useful to calculate annual growth rate. Harmonic mean is useful to calculate average speed. So when we discuss the formula, So this is the formula for RMS. The root mean square, you have a square plus b square divided by 2 whole root is always greater than and equals to arithmetic mean. So RMS is greater than and equals to arithmetic mean. Arithmetic mean is greater than equals to GM, and GM is greater than equals to HM. The formula for arithmetic mean, add all the values, divide by 2. For geometric mean, multiply the values and take a root. Harmonic mean, 2 divided by 1 over A plus 1 over B. For example, we have, this is the data we have. So in this data, if we use the geometric mean, we will get this side of the value. If we use harmonic mean, we'll get this side, geometric mean over here, and arithmetic mean is the center. That's where you will get the arithmetic mean. Now, if I wanted to put that into the formula, it's very simple. For arithmetic mean, x1 plus x2 plus x3 whole divided by n. So arithmetic mean x1, x2 up until x12. So because you have how many values? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Add them up and divide by 12. Simple. 313 divided by 12, 26.083. The difference between all of them will be slightly different. And like I said, it will be greater than equals to this, greater than equals to this. Like if you go back over here, you can see that arithmetic mean will always be greater than geometric mean, and geometric mean will be greater than harmonic mean. Now, harmonic mean, n is your 12. So I put 12 over here, divided by 1 over x1 1 plus 1 over x2. So this is what they have done. And then after solving, this is the answer. You can do that on the calculator as well. Geometric mean, 12 root and multiply all the figures, all the data you have. So the data is like, 8, 6, 1, this big massive value. You take the root and 12, you will get this answer. This is how you will calculate geometric mean, harmonic mean, and arithmetic mean.